Hello everyone. I wanted to introduce you to a technique for solving word problems involving systems of equations. I consider it to be a hack because it's a piece of insightful thinking that helps you gain entry to these problems. If you stall and stutter and get befuddled by word problems, this is a tool that may help you gain entry to these problems. In fact, since I just came across this method a couple years back, it's how I solve these problems. I can't do them any other way. So I'm hoping it helps. Now, what is the hack? Well, essentially what we're talking about here is finding the simple sum first. Now, I argue that if you take this approach fully, 90% of the textbook problems can be leveraged this way. Only a small subset can't. And so what problems can't be accessed this way? Well, they would be those involving distance, rate, and time. Kilometers per hour, miles per hour. In other words, those problems you're going to want to use the distance equal rate times time formula. Ubiquitously, not only in this chapter, but in other chapters. Whenever you see rates and time, think that formula. Okay, well, what is our simple sum? What is the hack? What are we looking for here? And it is, in fact, a simple sum. We're looking for two variables without any coefficients, but they have a coefficient of 1, that add to something that's in the problem. It's a simple sum. Let's go to MathXL online and let's check out a few of these problems here, and let's utilize the hack to gain entry to them. I'm going to start a palette of problems here. I'm going to start with the first one because it illustrates better than any other problem possibly could what a simple sum is. That first sentence says the sum of two numbers is 56. That is a simple sum. And so let me get Wolfram Alpha here. The sum of two numbers, x plus y, is equal to 56. Now Wolfram Alpha, if you're using this to solve systems, you want to put a comma in separating the two equations. And I'm going to put some white space here just because I want to make it more visible to us, the two equations. The white space isn't necessary. Now the second sentence up there says the first number is 2/5 of the second number. Notice that I can't say that x is equal to y. Can't say that. They're not equal. In fact, x is 2/5 of y. X is smaller than y. That's a true statement right there. X is less than y. If I want to use an equality symbol, I have to do something to one of the numbers or the other. Since x is 2/5 of y, if I took 2/5 of y, 2/5 of it, then I could in fact use the equal sign there. That would be legit. And there are my two equations and two unknowns. Now I'm going to go ahead and hit enter or return and let Wolfram Alpha do its magic. Let's scroll down. We see that there is a solution, an intersection point, and here are our two numbers. The smaller number is 16, the larger number is 40. They do in fact sum to 56. Okay, let's get this out of the way. What is the smaller of the two numbers? It is 16. Tab. What is the larger of the two numbers? It is 40. Now I'll ask MathXL to check my answer, and we get a positive affirmation. Okay, so we found the simple sum first. It was apparent as could be in that first sentence right there. The sum of two numbers is 56. It won't always be that obvious, but once you start looking for it, once you use this tool, you'll see it everywhere. 90% of the problems. Let's try problem 4. A basketball player scored 12 times during one game. So 12 times that basketball player put the ball through the hoop. Let me get my simple sum ready to go here in Wolfram Alpha. He totaled a total of 16 points. 2 for each field goal and 1 for each free throw. How many field goals did he make? How many free throws? Okay, my simple sum. Instead of using x and y, I'm going to get a little more descriptive here. Free throws I'll call F, and baskets, 2-point baskets, I'll call B. Now he put the ball through the hoop. The first sentence tells us he scored 12 times. He made 12 baskets. He put the ball through the hoop 12 times. So the free throws plus the basket is equal to 12. And there is my simple sum. Now, if I was working this on a paper, I would write let F equal the number of free throws. Let B equal the number of baskets. But I'm constrained here by the milieu I'm working in. So understand that that is an essential part of word problems, is making your definitions. But we have found the simple sum here, and now we use, since we're 50% of the way home, there's two equations, two unknowns, we've got one of them. We use what we found in that first one to find our second one. Okay, so we know that each free throw, and there were F of them, scored 1 point. So I want F times F. 1 times F. Each free throw was worth 1 point. That's the number of points total scored via free throws. For baskets, he got 2 points each. That's what that second sentence tells us. So I would multiply the number of baskets by 2 to find the total points scored that way. Now together, those two sum to his score for the game, which was 16 points. Two equations and two unknowns. I'm ready to hit enter. And let's see what Wolfram Alpha returns. A solution. The baskets is 4 and the free throws are 8. 4 times 2, they're each worth 2 points each, is 8. Plus 8 is 16 total points. So this looks like the solution. Let's go ahead and go back to MathXL and let it give us some affirmations. How many field goals did he make? In other words, how many baskets did he make? He made 4. Check answer. How many free throws did he make? Well, it was 8. Check answer. So we're doing quite well here. We are finding the simple sum. I'm going to do one more. How about problem 10? The Everton College store paid $1,727 for an order of 45 calculators. The store paid $11 for each scientific calculator. The others, all graphing calculators, cost the store $55 each. How many of each type of calculator was ordered? So I'm looking for the simple sum. There are two types of calculator. There's a graphing calculator and there's a simple scientific calculator. So I'll use S for the graphing calculator, G for the graphing calculator, and what is my simple sum? Let S equal the number of scientific calculators, let G equal the number of graphing calculators. Together, how many are there? Well, that first sentence tells us there's 45 of them. So I have found my simple sum. And now we go hunting to decipher the second equation. And you know that they are going to use S and G somehow, and whatever other information is there. In this case, it has to do with dollars. So S and G something is going to equal, and what does that say up there? The store paid $1,727. So the second equation is going to use the actual money paid. Now, S is the total number of scientific calculators bought. Each one of those the store paid $11 for. So I multiply that by S, and then the graphing calculators, each one of them, there are G of them, cost the store $55 each. And together, that means we add them, they cost the Everton College store $1,727. So that's it. I'm not so much interested here with helping you get this second equation. What I'm interested in is showing you that by going after this first simple sum, you have entry to these problems. For the first time, you have a hack that gets you started. It's a place of beginning. And I'm going to go ahead and hit enter here. Let's see what we've gotten back from Wolfram Alpha. Graphing calculators, there were 28 of them purchased. Scientific calculators, there were 17. Let's go ahead and enter these numbers into the MathXL to see if we get some affirmation. There was 17 graphing calculators. There was 17 scientific calculators. There was 28 graphing calculators. Check answer. Indeed, it was nice work. And the leverage into these problems was looking for that simple sum. 90% of these problems including all the mixture problems, all the chemistry problems, all the grain problems, can be solved this way. So I hope that hack helps you. Once you utilize it, there's no going back. I can't teach the solution to these problems any other way because I found this to be such a superior technique. Well, I hope that helps. I'll be talking to you again soon.